So we got 18 and 19, right? 18 and 19 deal with an in-center problem. An in-center is a triangle. When you take a triangle, Jonathan, when you take a triangle, and what you're really trying to do here is make a circle in the center of the triangle. So what's happening here is that right here, you're creating this circle inside the triangle. Okay? That's why it's called in-center. Okay? The center is in the triangle. So the in-center will always be in the triangle. So that is a question that you'll hear a lot on like tests, ACTs and stuff like that, okay? So, because there's another one called the circumcenter, and the circumcenter isn't always inside the triangle, okay? So the key thing about an in-center is that it's created by angle bisectors, okay? We talked about angle bisectors yesterday. So they bisect the angle here. Okay? So if this side's these two angles are equal, then it got bisected. If these two angles are equal, then it was bisected, cut in half, right? And if you can take two bisectors and find the center, okay? And the point from this to this point will also bisect that other angle. Does that make sense? Okay? So since we already know, given in this problem, that in 18, TJ and ST are angle bisectors, that means that TJ, right? So right here, we know that this angle is congruent to this angle. Okay? Because of the given. Okay? We also know that ST, so that means that this angle, right, and this angle are also congruent. With that said, I already know what that angle is without even finding it, right? Because it has to be how much? 14. Yeah. Pretty easy, right? So we're just going to kind of label that just because, why not? You see it, it's easy. Let's do it. Okay? Then we'll go back over here and start doing our two-column proofs. Because what we need to be able to do always is two-column proofs, right? So on your whole test, it's nothing but two-column proofs, two-column proofs, two-column proofs. And I push this way more than any other school. But it's because I want you to know how to do the problem, not just find the answer. Because a lot of you will find the answer by being lucky. Well, it's either equal or as the 180, I'll do one of them, and I got a 50-50 chance of getting it right. As long as my algebra is good. Okay? And that's what a lot of students do. They have no clue how they're getting it right. Okay? And then they get on the test, like my daughter, and they fail it because they don't know why they were getting it right. They just do, they did all of it right on the quiz. Well, why did you set those equal? Oh, right? So, sounds familiar? So that, and they don't know these two-column proofs. They don't do them. And so we're going to do them on every single problem. And it's really easy. They gave us TJ, right? So we just say TJ and SJ, right? Are, we can say are angle bisectors. And that's given. That's not bad. Right? Okay? With that known, there's some things I know about that. That means these perpendiculars from the in-center are also congruent. Now here, they're not talking about an angle, they're talking about a distance, right? So what we want to do is go after the distance. If we're looking for a distance, RS, right? So we're looking for this distance, RS. Where's RS? RS? Oh. From here to here. Oh, no. J, they want to know this distance. Okay? From J to RS. Right? Now here's the thing. If this is the end center, right? Then this distance is going to be the same as all the other end centers, right? So we need to prove that it's an end center. How? Oh, not that one. Sorry. That one's normal. How can we prove that this is an end center? No? No, good. That's nice. I like it. And that would be one way, right? If we drew it to scale. I like it. No, we say, hey, what is the point of an end center? We have to have angle bisectors, right? So do we have angle bisectors? Yeah, we have two of them. And where do they meet? Yeah, at J. Which means, since these are both angle bisector, that makes J the end center. So therefore we can say 2. J is the end center. Why can we say that? Definition of end center. Okay? Because you need to have two angle bisectors that meet to create an end center, which they gave us, right? That makes J the end center. If J is the end center, then any line that's perpendicular or congruent. So because of that, we can go to the next one and go, well, that means that J, oh, is this a point? I should have a point. We'll have to make up a point. Let's call this X. Because it doesn't have a point. Or does it? Yeah, K. Sorry, this is K. But this doesn't have a point. So we'll call that X. Okay? So what it means is that this perpendicular, which is the shortest distance to the line, right? This perpendicular, JX, is going to be congruent to JK. And why? Why is it going to be congruent to JK? Just kidding, joke, right? No. JK, right? You're missing my jokes, man. Okay. So why is it congruent? Because it's the end center. It's a perpendicular. These are perpendiculars. So therefore, they are, by definition, of an end center. Okay? By definition of an end center, they have to be congruent. Okay? Well, do we know what JK is? And doesn't AT tell us? Oh, it's listed right here. It says JK is 8.37. So it says that JK equals, what was it, 8.37? And that's a given, right? Because they gave it. And so how far is JX then? How far is that distance? So all we got to do is plug it in. So 5JX is equal to, plug it in, 8.37. Why? Well, what's it called when you plug something in?